what we learned about the big O notation of push and pop operation in the stacks. So if you remember, we mentioned that when we want to push an element into the stack, or we want to pop an element out of the stack, it shouldn't matter how many elements we have in the stack. So we want to see if our stack, it's going to look like this, or it's going to look like this. So basically, is this the top or is this the top? Is the head the top or the tail is the top? If we want to answer this question, if you want to push an element here, if we consider the tail as the top, there's no index in the linked list, right? So we can't easily just insert an element here. If we want to insert an element here, we have to traverse through the linked list. So we have to go through as many nodes as we have in the linked list, right? So if we have 4 elements, it takes us 4 iterations to get to the last node, right? If we have 40 elements, it's going to take us 40 nodes to traverse, 40 iterations to traverse through the linked list. So this is not the case, because I should say like order of 1, not order of n. I made a mistake. This should be order of 1, not order of n. If I made that mistake before in the previous video, I'm sorry about that. It should be order of 1, not order of n. So it means that like it should be a constant time for inserting an element, not shouldn't be dependent on the number of elements that we have in the stack. So this is what we want to have. Like the head is gonna be the top of the list, or top of our stack. So if we want to insert or push an element here, then it should be changing our head. Our head is gonna be the top of our stack. So if that's the case, how can we implement the push and pop? So the push, it's gonna be as simple as just having an extra node, allocating a new node. So let's say like we have a pointer to a new node, right? And it's gonna be making this element. So like first thing that we have to do is, like, because this is a new node, so we're gonna have a node star t equal to new node. And then we want to make this we want to make the next pointer of this new node that we implemented, allocated. We wanted to point to what the head pointer was pointing to, right? So we want to say that t arrow. First of all, we can put the data here. So like whatever data we want to push in this stack. So let's say like we want to push number 5 in this stack. So we want to put t arrow data is equal to the argument that we want to put here. So let me just call it argument. So this 5 goes here, or let's call it data, D. and then we want to make this pointer point to the previous head of the linked list, or the previous top of the stack. So T arrow next is equal to, what should I write here? We want this pointer to be pointing to where head was pointing to. So T arrow next is equal to head, or which is also like the top. And so then the next thing we want to do, it's basically, we want our head, which is now, we call it top, it's going to be pointing to the new node. So top is equal to T. So this is how we can implement the push function. Okay, so it's going to be as simple as having a top pointer, right, which we can initialize it as, what should I initialize the top pointer as? If you have an empty list, means that this is going to be null. And then as you want to push new elements into the linked list, this is the operation that we should do, right? We should allocate a new node, insert the data into the node that we just allocated, make the node, the pointer part of the node point to the previous top of the linked list, and then also make this pointer point to the head pointer, or the top pointer points to the newly allocated node. That's basically what's gonna happen. So this is what's gonna happen now. So like we had, like, let's say 40, 30, 20, 10, and then now we have 5 on the top of the stack. Okay, so the head of the stack, head of the linked list is the top of the stack. So that's how we can implement the push part. How can we implement the pop part of our pop operation? So this is how we do the push. How can we do the pop of the linked list? So this is push the pop part. Okay, so what we want to do, we basically want to remove the head of the stack, or the head of the linked list, or the top of the stack, right? So what we want to do, we would basically want to have this top pointer, we want it to be pointing to the new to the second node, right? So like, first of all, again, in the push part, right, we have to make sure that we don't have any